One day it might work right. We're still working on how to do that. But now it's at least driving in the right direction. 12 blocks is a pretty fully functional programming language in and of itself, in that I can, if I want, create my own user interface function, a little user function here to kind of do a little bit more processing. I can move blocks from one place to another, and I'm going to use another kind of block. This is an if block here. So, as you can see, I can kind of just stitch my program together. These if blocks are nice in that once I put it down and I decide I need an if else block, I can just click and it becomes an if else block. And what I'm going to implement here is a little bit of logic that implements the deadband. So the hard part right now in controlling it is that the joystick doesn't go back to 0 all the time. There's just mechanical issues with these gamepads. So it might go to plus or minus 50 when I release it, but that still moves because the drive is sensitive even to low values. So if I am going to add here a little bit of code to, if the Y value is more than the deadband, or the Y value is less than the negative value of the deadband, go ahead and drive based on that value. Otherwise, you are 0. If I want to, I can copy that entire block with all the code that exists and paste it down here. So as you can see, it's actually pretty easy to generate a pretty complex program, or at least one that picks up, might look complex when you're looking at it. Quite quickly, we can generate a pretty useful program here. So now it's going to, when I'm inside of a deadband of the joystick, it's just going to be 0, which will make the robot drive a lot more like what the joystick is actually doing. When I want to use that function, it shows up here in my, under functions, this block here, and I can drag it to the place that I want. One really cool function is there's automatic refactoring. So if I rename this function to handle joystick, the places where I've used it automatically change, and in the tool library it changes as well. So, trying to be safe enough that I don't roll this thing off the table. Yeah, that's good. So now it's a lot. Now I can just kind of let go of the joysticks and it stops really nicely. All right. So that's using 12 blocks to kind of send variables to a running program. But it would also be useful to be able to do it the other way around. Why can't I grab a variable in a running program and bring it back to 12 blocks to view? In fact, we can do that. So a useful thing to do would be, the robot has some line sensors on it. So I need to enable line sensors with this set pin high block that'll turn on the infrared transmitter on my line sensors. They use a little bit of power, so the robot by default keeps them off. And then all I'm going to have to do, think and program at the same time. I'm going to use a trick that I'll explain in a minute. But basically, I'm going to pull a sensor value, read line sensor, plug it in there, and it's probably obvious. There we go. I'm going to read the line sensor, and okay, so now I have it all set up that make it drive by itself just to make this more interesting. Set the robot somewhere more interesting. And all right, so now you can see values coming back from the robot are being graphed, displayed here on the side, and graphed on the bottom. So this is a really useful way of taking data that's running out on the robot. Like this could be maybe the control values for a PID loop, something that would be really difficult to tune, but if you can visualize it, you can bring it back into 12 blocks, it makes it a lot more obvious what's going on. So what I'm doing right now is actually putting variables into, well, a special thing, not necessarily just in 12 blocks, but it's something that the robots are using. It's a shared memory amongst all of the robots. So one of our communications mechanisms that the robots will use for talking from one robot to another is this shared array, this world array. And I can view that when it's in 12 blocks, I can view the values in that array. So what I did was I read the sensor value and I stuffed it into the world array. We can actually use that value for controlling more than for robots to talk to each other. So, what I'm going to do next is I'm going to start with another, create another program. You can see, okay? I'm going to create another program, and all of this, I'm going to put this in a different robot, and all this program is going to do is read from the world array and drive the robot based on the values that are in that shared global memory. All right, I get to it in 12 blocks by using a special array accessor, but it's pretty easy to use. So I'm getting the value of two values out of the world array, setting them into a variable, and then just setting the motors to drive based on those variables, which is about as simple a program as we can do. I'm going to pick a different robot to put that in. Let's put that in robot number 2. Which one is robot number 2? Yeah. All right, we'll put them both kind of in the same spot. All right. Let's do one more thing here. Go ahead and use that LED to kind of tell us which one actually is programmed here. And so I've loaded that into robot number 2, and it's just a green LED on one of them. It's the winner. Okay, so now we'll go back to the original program, or the other robot, our longer program that we've now added. This broadcast world, which I kind of glossed over when I put it on there, this is how the red robot is going to say, I'm going to take ownership of the world array indexes 0 and 1. Okay, so anybody can read from them. I didn't have to do anything special to read from them in the slave robot. But for the master robot, I'm going to go ahead and broadcast to those values. Okay? And now, so I extended what I was broadcasting, and what we'll do is, since this one's already going to be controlled by the joystick, like we were doing before, I'm going to use those calculated joystick values, but make the other robot drive opposite. It's fairly arbitrary, but the important thing to understand is I am controlling the red robot with the joystick, but the blue robot is being controlled by the red robot. That could be anything we want. It could be based on sensor values or shared sensor values or some kind of shared decision making or whatever's appropriate for the multi-robot application.
3 minutes.
Let's see if I can do this without driving anything off the table. And it's not working. I disabled the motors on one robot at this thing. So now you can see that the red robot is responding to the joystick values, and the blue robot is listening to the red robot, which is just telling it to do the opposite thing. Okay. And of course, one cool thing that we can do is we can program all of simultaneously, and then things get really interesting when the one isn't disabled. So that's everything that I have. I'll go ahead and stop there. Does anybody have any questions about 12 blocks or the robots? Yes. 12 blocks. Well, I think the original name was a challenge, what can you do with 12 blocks? From there we found that generally we use more than 12 blocks, but they're still quite powerful. No, I don't. The shared memory is completely in the swarm of the robots. They'll handle that all by themselves. Obviously, to get the joystick values to the robots, I need 12 blocks has to be running. Any other questions? Yes?
Has 12 blocks been released yet?
12 blocks is released. In fact, everything except for the XP that you saw, because that's tied to the robots, that you saw today is in the latest version available on UPENE's website, 12blocks.com. We just updated it like yesterday, so there's a very, very updated version of it.
Will the XP stuff be folded into the standard 12 block?
I believe yes. It will be, when we figure out how we're going to do that, fold it in to be available with 12 blocks. That will be up to UPENE though. Any other questions? All right, then that's all I have. Thank you.
Ha ha ha!